All right, guys, your warm-up is to do this entire first page of your notes. Go ahead and read the question, try your best, and when you're done, call me over and I will check before you move on. So go ahead and pause the video right now and work on the entire first page. Okay, so what you just were working with were matrices. These right here are matrices. This is a matrix. A matrix is a way that we can organize data, and today we are going to be looking at how to, what to call matrices, how to add and subtract, and multiply. So let's take a look. To describe a matrix, we use its dimensions, and the dimensions, we always talk about rows by columns, okay? So rows by columns, what do I mean? Let's look at this first matrix. How many rows are there? 1, 2, 3 rows. And how many columns are there? There are 2 columns. So we put a 2 there. So what we say is this is a 3 by 2 matrix, okay? That's how we describe these matrices. So go ahead and pause the video right now and work on number 2 and 3. Call me over when you are done, and then you can move on. Okay, so when we are adding or subtracting matrices, write this down, please, that we're going to say entries in same position. Okay, so what that means is we can add or subtract entries in the same position, and the result goes in that same position. And you'll see what I mean when we start working with it, but I want you to write this down. Dimensions must be the same to add or subtract. So what does that mean? So if I give you a problem to add or subtract matrices, we have to first double check that their dimensions are the same. So let's look at number 4 right here. What are the dimensions for this matrix right here? This is a 2, right? 2 rows. How many columns? 1 column. So this is a 2 by 1. And what are the dimensions for this other matrix right here? This is also 2 by 1. So can we add those? Yes, because the dimensions are the same. Now when we add them, we're going to get a answer that is also a matrix. And if what kind of dimensions do you think this answer matrix is going to have? If you guess that it's going to be a 2 by 1, you are correct. All right, so this 2 by 1 is not part of your work or answer. It's just for me to show you. If it's going to be a 2 by 1, what I would do if I were you is just make myself a little like little filler lines. Like, okay, I know I'm going to have 2 spots here that I'm going to need to fill in. Okay, how do we add these? You look at and add entries that are in the same position. So, for example, if you look at those first top entries, 2 and 6. 2 plus 6 is 8, and you just put that in the top entry in your answer matrix. Okay, now same deal. Look at the bottom entries. What's negative 3 plus 2? Negative 3 plus 2 is negative 1, and if we put it in the bottom, if we use the bottom entries, we have to put it in the bottom, our answer. Okay, this right here, this matrix, this is our answer. I don't really like that highlighter. This matrix right here is our answer. Okay, so if we look at number 5, what are the dimensions of number 5? Well, they both look like a 1 by 2, so I know my answer is also going to have to be a 1 by 2. And just to remind myself that I'm going to have 2 places to fill in, I can just put little filler lines there if you're someone who forgets how many numbers you're going to have. So, negative 4, I'm going to compare the first, I'm going to compare the first number with my, right here and right here, the first left numbers. Negative 4 plus 2 is negative 2. And now I'm going to compare the second, the right number. 0 plus negative 3 is negative 3. Okay? Now, you are going to look at number 6 and notice that this is a little different because A, the dimensions are different. what size matrix is this going to be? This is going to be a 2 by 2, right? Because the things we're adding, the matrices we are adding, are 2 by 2s. Also, we are subtracting. So go ahead and work on number 6. Make sure that you are doing 6 minus negative 2. That's top left. You're going to put that difference, 6 minus negative 2, into the top left right here. Okay? Work on 6 and 7. Pause the video and call me over when you're done before you move on. Okay, matrix equivalency. Entries in the same position in a matrix, those are equivalent. So if two matrices are equal, we can say that entries that are in the same position are equal as well. All right, so let's take a look. We can compare, so if these two matrices are equivalent, and if they're equivalent, they should have the same dimensions, right? What are the dimensions of this? How many rows? 2. How many columns? Now, I know there's like 2 terms right here. Technically, it's just 1 entry, okay? 1 column, 2 columns. So this is a 2 by 2. My other one on the right is also a 2 by 2. So just making sure. Now, our answer here is not going to be a matrix. We're just trying to find the value of the variable. So we're just going to have, x equals, y equals. It's just going to be a list of what the variables need to equal. So when we compare, we can compare entries in the same position. W plus 3 and negative 2, okay? Those are going to be equal. Oopsies. Those are going to be equal to each other. So we're going to do W plus 3 is going to be equal to negative 2. So W equals negative 5. Okay, that's one of our answers right here. All right, what about, let's try another one. Let's try 2 minus x and 5, okay? Top right, and I can set them equal. 2 minus x equals 5, negative x equals 3, x equals 3. Negative 3, I'm sorry. Negative 3, okay? That's one of my other answers. So I have 2 answers. I need 2 more, right? I need to solve for y and I need to solve for z. So go ahead and pause and solve for y and z and call me over when you're done before you move on. Okay, now that you've found y and z and I checked your answer, let's look at number 9. Again, this is a 2 by 1 matrix. This one on the right, I know might look like a 2 by 2. It's not. This right here is 1 entry, and this is 1 entry, okay? When you add x and y, it's going to give you just one number. So this is also a 2 by 1, okay? Just for reference, okay? We don't really need to know that, but I just want you guys to see. So we're going to compare these top entries. 17 equals x minus y. And also, these bottom entries. 7 equals x plus y. Oh, what does this look like? My favorite thing, Miss Savis. These are systems. This is great. I know how to solve systems. That's what I was working on all last week. Go ahead and solve that system for x and y, and call me over when you're done. Pause the video, call me over when you're done, and then you can move on. All right, solving for a matrix. Let's take a look here. There's 2 ways we can do this. Now, matrix X is a matrix. What do you think? What size do you think matrix X is going to be? Let's make a little educated guess here. If I have this matrix is a 2 by 2, what do you think matrix X has to be? I'm adding them. And what are dimensions for things that are adding? What do they have to be? They have to be the same. So matrix X, I'm just going to put it down here, okay, if you don't mind. Matrix X needs to be a 2 by 2. And I'm just going to make sure I put little lines here for my entries. I know I need to put 4 numbers in there. Okay, so there's a couple ways you can do this. You can just think, all right, I need to put something here, and I know it's the top left. So top left plus top left needs to equal top left over here. Does that make sense? So something plus 2 needs to equal 7. Well, that's 5. Something plus 0 needs to equal negative 4. That's negative 4. Now, there's another way you can do this, and you could keep filling it in this way. Something plus negative 3 is 2. That's going to be 5. And something plus 1 is negative 5. That's going to be negative 6, okay? So that's one way to do it. I'm going to erase that. Another way is you can think about this just like any other equation. That's probably what a lot of you wanted to do right away. Is let's say this was x, y, and z. So we have x plus y equals z. What would you do if I told you to solve for x? Well, you'd subtract y, right? You would do z minus y. So same thing. This is just matrix z and this is matrix y. What you can do is write matrix x is going to be 7, -4, 2, -5. So that's matrix z minus matrix y. All right? So you can do that too. That works out great. And then when you subtract those, you will get the same answer. Go ahead and try number 11, however you'd like to do it. Pause the video and then call me over. All right, last one. If we want to do 3a, what do you think we're going to do? Well, I'm just going to rewrite this, but instead of a, I'm going to write what the actual matrix A is. All right, so 3 times matrix A is 9, -3, -21, 0. Anyone want to guess what we're supposed to do now? If you said we have to multiply 3 by all these entries in here, you would be correct. So 3 times 9 is 27. 3 times -3 is -9. 3 times -21 is -63. And 3 times 0 is 0. So looking at number 13, this one is a little bit, same thing, right? We're going to have to multiply 2 times b. But when you're done with that, you're going to need to subtract a after that. All right, so go ahead and pause the video, try that. When you are done, please have me come over and check it, and then you are done with the lesson.